All right, the next example I want to do is I want to look at the following definite integral, and I want to show you how definite integrals work with trig substitution. So I want to look at the integral of 1 over square root of 4 plus x squared from 0 to 2. And here we're going to substitute x as 2 tangent theta, or dx is 2 secant squared theta d theta. And then we're also going to change the bounds. This is a substitution problem after all. And so what we're going to do is we're going to figure out, well, if x is 0, what does that mean? Well, that means that 2 times tangent theta is 0, which means tangent of theta is 0, which means that theta itself is 0. And if x is equal to 2, then 2 is equal to 2 tangent theta. That tells you that tangent theta is equal to 1, and therefore theta is equal to pi over 4. And so instead of going from 0 to 2, we're going to go from 0 to pi over 4. And now we can just keep everything in terms of the new variable, and we don't have to go back and substitute back in and use the triangle. We don't have to worry about that unless we need to somehow figure out, unless our answer involves like sine of theta or something. So maybe we do actually, but anyways, so this is the integral from 0 to pi over 4. We're going to have, in the denominator, we're going to have the square root of 4 plus x squared. So it's 4 plus 4 tangent squared theta. Our dx is 2 secant squared theta d theta. And that's going to be the integral from 0 to pi over 4. I can do a few things. And since we've done this a few times, if you're comfortable with it, I'm just going to rewrite everything all in one step. So we can factor out the 4 from the bottom. That's under the square root. So when we take a square root of 4, that's a 2. And that's going to cancel with this 2. So those all cancel. Okay. And then this 1 plus tangent squared is secant squared. So this is going to end up being secant squared theta over secant, which is just secant theta. And the integral of secant theta is going to end up being the natural log of the absolute value of secant theta plus tangent theta. And then we're going to evaluate from 0 to pi over 4. No, we don't need the triangle. So when we plug in pi over 4, let's think about what's going to happen here. We're going to have the natural log of secant of pi over 4. So I have to figure out what that is, plus tangent of pi over 4, okay, which we know is 1. And then we're going to subtract the natural log of the absolute value of secant of 0 plus tangent of 0. So this is the natural log of, let's see, so cosine of pi over 4 is 1 over square root of 2. So that means that secant of pi over 4 is square root of 2. Tangent of pi over 4 is 1. Square root of 2 plus 1 is a positive number. It's like 2.4 or something, so we can drop the absolute value. And then we're going to subtract the natural log of, well, secant of 0 is 1, because cosine of 0 is 1, and 1 over 1 is 1. Tangent of 0 is 0, and we get the natural log of 1, which happens to be 0. So altogether, this is the natural log of the square root of 2 plus 1. So the natural log of the square root of 2 plus 1. Okay, so that's definite integrals with trig substitutions.